back to Advent of Code, day 14. Extended polymerization. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. There's an interesting HTML bug in my proxy. The submarine manual contains... what do we think that's likely to actually say? Oh, we just ignore that, don't we? I think the submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules, your puzzle input. You just need to work out what polymer would result after repeating the pair insertion process a few times. For example, so the template is NNCB and the insertion rules are CH to B, HH to N, CB to H, and so on. So I think, assuming we apply these in order, we'd apply CB to H and we'd have NNH, and then we'd apply NN to C and we'd have CH, and then we'd apply CH to B and we'd have a B. So it would end with a B. The first line is the polymer template. This is the starting point of the process. The following section defines the pair insertion rules. A rule like AB to C means that when elements A and B are immediately adjacent, element C should be inserted inserted between them. These insertions all happen simultaneously. So starting with the polymer template NNCB, the first step simultaneously considers all three pairs. Okay, so then we'd have NCN, NCN, BCHB. Note that these pairs overlap. The second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of a pair until the next step. After the first step of this process, the polymer becomes NCN BCHB. Here are the results of a few steps using the above rules. Okay. This polymer grows quickly. After step 5, it has length 97. After step 10, it has length 3073. After step 10, B occurs 1749 times, C occurs 298 times, H occurs 161 times, N occurs 865 times. Taking the quantity of the most common element, B, 1749, and subtracting the quantity of the least common element, H, 161, produces 1588. Apply 10 steps of pair insertion to the polymer template and find the most and least common elements in the result. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? I wonder what's the best way to do that. I also wonder if every pair always has something that gets inserted into it, or if there are only some insertions. So there's 102 lines. That means there's 100 insertion rules. So for every pair to have an insertion rule, we must have only 10 letters. So we've got V, S, F, O, C, N, P, H, K, V, B. That's more than 10. Or is it exactly 10? V, S, F, O. Okay, well, I'm going to silently contemplate for a little while. Okay, well, I think I've got an idea then. what was the top thing called? A template. So left, right, place. Okay, and then we want a up to 100 by 100 grid. Sorry, up to 10 by 10. So Jez told me I should write less than instead of not equal because I'm less likely to get it wrong. The problem is less than is very expensive because I don't have a carry flag, so it's like quite a lot of code. But we'll roll with it for now. And in this context it won't matter. It's only in the innermost loop it really makes any difference. While I is less than 10, map I is malloc 10. And we'll set them all to -1. So that builds our mapping, and here we want to go map from letter left to letter right is letter replace. And letter will be a function that maps from letters into digits 0 to 9. Okay, that will look about letters. That builds our map. We've already written the template. So when we finish building the map, we want to go we'll have a recursive function that will apply the rule to its arguments. I expect this isn't going to be good enough for part 2. I think we need to be cleverer for part 2. But let's just say, what are we going to call it? Run pair. And this will be letter of template I. It's a letter of template, oops. It's a letter of template I plus 1. We also need to have a count of the number of each one, which initializes to 0, and the run pair function. Maybe instead of next letter, we'll call that number of letters. Okay. oops, run pair is a function of left and right. So if the map from left to right is minus, well, we'll assert that the map from left to right is not minus 1. And then we'll just, oh, we need a number of levels to do. So we'll start out doing 10 levels. If levels is 0, then we'll just count the characters we've got. So count L equals count L plus 1. Count R equals count R plus 1. And then return. Now we assert that we have a map, and then we just run pair from L to map LR on levels minus 1. And we run pair from map LR to R on levels minus 1. And then at the end, we have to find the largest and smallest count, subtract the smallest from the largest and print that. I wonder if it's going to overflow 16 bits. Okay, what are the chances I've done that correctly? Maybe we'll put some debugging output in preemptively. So we'll say what the letter mapping is. Yeah. We can say what the count is for each one as well. Oh, actually, we can put this in letters and numbers. So this is letter character I goes to counter I. Okay. I think I failed to put an argument on this. So the thing we need to do for part 2 is memoize run pair. And in fact, we might be able to do it the other way around. We might be able to make a table that has number of levels left, right, and maps to the count of each character, and then we build it up from the bottom instead of from the top. And then when we've reached the number of levels we need to get to, we just look at every pair in the template string that we're given and read the values out of the table. How big would the table be? 10 characters, 10 left, 10 right, and how many levels? So that would be 1,000 times the number of levels, which might be quite big. Although, we don't need to hold all the number of levels at once. As we build up, we only need to store 2 levels. So that would be 2,000 cells. So that would fit. Anyway, maybe we'll have to do that for part 1 if part 1's too slow. I don't think that's the right answer. What did the problem say? Oh, that says after step 5. After step 10, it has length 3073. B occurs 1749 times. Oh, I've double counted everything. What's 1588 divided by 2? Sorry, times 2. Yeah, so I've just got the answer but doubled. So if I halve the output, I might have it right. I've double counted everything because every letter goes into two sides of the recursion. How long do we reckon this will take? Oh, okay. So, that's an odd number. That's not a good sign, is it? Oh no, I'm supposed to halve it, aren't I? Stupid. So I think it's 3009. I think the problem is that the first and last character of our string only go into one side of the recursion. So B and N will be one short of in our doubled count. So let's see. So the most common is N, so we'll say that's 8176. And is B the least common? No. O is the least common, so that's 2158. Yeah, and divide that by 2, we get 3009. Yes, okay, good. So, dirty tricks there, but we got the answer. And I expect this will be exactly the same, but we have to do 1,000 levels or something. 40 steps. Well, I might, rather than doing the bottom-up version, I might just try to memorize the version we've got. Would it be easier? So what's 40 levels times 10 times 10 times 10 is 40,000 elements. That's too many to store all at once. I really need a utility function to make multi-dimensional arrays for me. So we'll only memorize. Should we just do it bottom up, and then we'll just keep two copies of the known array? So then we'll only have. Yeah, we'll do it bottom up. Okay, so we can delete a lot of this. So we'll have starting at level 0, and we'll have we want a count map. So we want 2 of these actually, one for the level we're working on and one for the level below the level we're working on. So we'll have current and below. And these will map, and we'll just swap the pointers at the end of each iteration. So we want to know what is the number of characters we have like that. So at the bottom level, where we have input like A, B goes to C, what we'll say is, okay, we'll do the letter ID thing, but current A, B, we know that AB actually goes to ACB. So current AB, A is 1, current A, B, C is 1, and current A, B, B is 1. I think we'll still do the thing where we overcount, where we double count everything except the first and last character. But we can actually manually touch that up, can't we? So, well, what's happened is I spent a long time pursuing a dead end of this dynamic programming solution where we tried to build up the table. And then I took a break and I looked at Charlie's solution. Charlie's solution was much simpler. So what I've done is I've edited out all of the boring stuff where I messed up trying to implement the dynamic programming solution, and we'll cut back in to, we rejoin the action. What I've done is I've looked at Charlie's program and I've decided that his way is much better than mine. So we're throwing away this complicated table system. And we're just going to do it the same way that Charlie does it. Okay, so we can throw away everything after here. And instead of having that table, what we're going to do is count in our input string how many we have of each letter pair. And then we're going to loop 40 times and say that we now have more of each letter pair based on what the map tells us we should have. So, actually I still want this part. So now we go over the input string. Oh, come on, man. And then count of pair LR equals count of pair LR plus 1. And then for each level and for each pair, we want to say the count of pair. So for each mapping LR to LMR, for example, we want to say that the count of pair LM gains count of pair LR, and count of pair MR gains count of pair LR. Okay, so is it definitely 10? N letters. So we need a new count pair. So let's do it. So then, when we're here, let's make, oops. Let's say M equals map from L to R. And then new count pair from L to M gains however many pairs there were from L to R, as does pairs from M to R. And then at the end, we just swap count pair and new count pair. And then at the end, we need to add up the letters. So we want a count for each letter. So count equals, so model 10. So count of L gains however many we have of the pair LR, and count of R also gains however many we have of the pair LR. And I think again we're failing to double count the first and last character. Let's run it without doing anything. I want the bottom of part 1 included in part 2. So I want the thing that's going to take the counts. Yeah, I want this bit. So if I do that, and then cat part2.sl and bottom to F, then I think F should be what I want. Yeah, so we'll move F to part 2. And that's how we copy and paste on SCAMP. Okay, and that's an awful lot simpler than the table system was. So let's build that and see what happens. We'll still need to do the big int thing once we've made it work. Did I write an infinite loop? Looks like I might have done. Yes, we don't increment I here. Okay. Well. Okay, after one step we have 0 of anything. So, what's the problem there? Yeah, okay. I made this mistake again. Template is a string of characters, not a list of numbers. Right, so after one step, I think we've got 4 C's, which is just double counting the C's. We think we've got 2 H's, which is just double counting the H's. We think we've got 3 B's, which is 1 short of what it is, and we think we've got 3 N's, which is 1 short of what it is. 8 C's is double counted. Oh, we just need to add on 1 for the start and end of the string, don't we? And I think we're there. So what did we say for 10? I think we've just double counted everything except the first and last. So template 0, R is letter, template, strlen template, -1, and then here, that then ought to give us the correct answer. And then we just need to make it do big ints and run it for 40 levels. Okay, I think that was correct. So, what do we say on our real input? Was it 3009? Yep, great. What do we say for 40 levels? No, we need big ints. Okay, good. We're getting somewhere though. Let's see. So, count pair. These want to be big ints. So, we don't need Z in malloc anymore. Do we have a var j? I don't think so. Count pair ij is big new 0. New count pair ij is big new 0. Now let's try and be really careful and get it all on the first try. So, count pair and new count pair both have 100 big ints. Do we want them? We'll just leave them at 64-bit. So, here we want to big add to count pair LR1, and that's big add W, because we're adding a word and not a big int. Okay, this wants to reset them all to 0. So, big set W, new count pair ij to 0. And now we want to big add to new count pair LM, count pair LR, and we want to big add to new count pair MR, also count pair LR. That looks right. We swap the pointers to the arrays the same as we did before, but count also needs to be 10 big ints. and down here. Okay, here we big add 1. Min and max. What if we set those to null pointers? And then, if not min, min equals count I. Else if big comp count I min is less than 0, min equals count I. And if not max, max equals count I. Else if big comp count I max is greater than 0, then max equals count I. So min and max are now pointers to the big ints. But that's fine. So now we'll just subtract min from max, divide it by 2, and print it out. Okay, and with any luck, I got all of that right. So this should tell us 3009. Please work. Okay, good. The counts are wrong because the counts are pointers, but the final output is correct. Okay, great. All right, let's submit that. Three, four, five, nine, 822, 539, 451. Yay. Oh, we got there in the end. Right. There's some stuff we can tidy up. We can get rid of all the debugging prints. That doesn't need to be there. Part 2, number of levels wants to default to 40 rather than 10. That print can go. I think that's all of the prints. So yeah, Charlie's idea, much better idea than my idea. The advantage of what, if I had done my idea, one advantage would be that given arbitrary strings, you can look up how many characters you end up with straight away without having to redo your loop of 40 levels. But we only have one string to work with, so it doesn't make any difference. Quite a good problem today. Yeah, it's a shame I convinced myself that the dynamic programming solution was the way to go. And this one doesn't need that. Great, well, that's the end. Thanks for watching. Goodbye.